Hello, everyone. In today's exercise, we will try to build such a project where we will first try to turn on and off different dots on our 8x8 matrix. Then we will try to see how we set entire rows or columns. After that, we will try to write our math in this 8x8 dot matrix. I already have the project halfway done. The students will finish it on their own after watching this video. So let's just start from the basics of this project. I'm gonna come to Arduino and I will open a new sketch. We always save it first. I save it as matrix letters exercise and let's first see how to turn on this matrix. We need to use these 5 commands to do that. I will just copy it for it to be faster. And let me explain what each of them does. First, a very important point. When students try to do this at home, it's not going to compile, and let me tell the reason why. In order for it to compile, they already know how to do this, many of them do. They need to add the library. The library is the list of commands that this matrix can execute, so they need to add this to the program. To do that, they come sketch, include library, add .zip library. I've already showed how to do this in our very first video about how to connect the breadboard. I'll leave the link in the description. They already done this at the class too. And let me say again, I already have it in my computer. Sketch, include library, add .zip library. After this, they need to select the let control.zip. Let control.zip is in the folder with all the codes and libraries that I already sent. In the folder that they downloaded with the book and the codes, there's a folder called libraries, and let control.zip is there. After they do this, let me compile. This just declares that there is a dot matrix connected to 12, 10, 11. And after that, turn it off. And these 3 commands just show the blank display. Let me also show the connection diagram. For the connection diagram, they would need to, let me make this smaller. For the connection diagram, they would need to connect VCC to 5V, GND to GND, and then the DIN, CS, and CLK to 12, 11, and 10 respectively. This is on page 112 of the book that they have. I'm using the same tutorials as always, the same kit as always, educational kit. After we do this, it just turns on the matrix. So if I upload this, it's going to just show a blank screen. Nothing is on display. Let me turn on one LED. To do that, the command is lc.set LED. I start with 0 and then the number of the row. The 3rd row will be 0, 1, 2. The counting starts from 0, and the 5th column will be 4, and true will turn it on. Let me leave it on for 500 milliseconds, and then the same thing again to turn it off. To turn it off, instead of true, I do false. So 500 millisecond on, 500 millisecond off. I always compile, and then I upload. In my case, the counting for rows starts from here, 0, 1, 2. The counting for columns starts from here, 0, 1, 2, 3, 4. So this is 2, 4, this dot that's blinking. You can, like, for example, turn on like 4, 1, on and turn it on and off. See, now it's 0, 1, 2, 3, 4, 0, 1. After doing this, let's try to turn on and off an entire row or an entire column at the same at the given time. To do that, I replace the turn off individual light by clear the entire display. It is lc dot clear display 0. And to turn on entire row, it will be, instead of set LED, it will be set row. I can start bit 0, then I wanna do it on row 2, and which dots are on and which are off is written in the following way. I will start with the B because B stands for byte, and then 8 numbers, 0 or 1. Ones are on, zeros are off. For example, on, off, on, off, on. The number of numbers need to be exactly 8. 1, 2, 3, 4, 5, 6, 7, 8. Let me show you what this does, and then I'll also explain. So this blinks again. See, 1, 1, 0, 0, 1, 0, 0, 1. So 1 stands for on, 0 stands for off. If I do the column, and by the way, the rows and columns, if you hold it different way, it's going to be different. So each student should do this on their own and see how it works for them. And one more thing, they shouldn't connect the matrix to a breadboard or some random open spots on the Arduino. These are connections you just, they should just leave the matrix like this. Instead of row, now let's turn on a column. I will hold it like this and upload for you to see the difference. It's the 90-degree rotated version. Again, on, off, on, off, on, or 1, 1, 0, 0, 1, 0, 0, 1. After doing this, let me show you a method they can write the letters. They can either do this on a piece of paper and just draw them one by one. The way I do it is, there is this, if they Google nonogram 8x8, there is this puzzles called nonogram. And here you can solve the puzzle, but obviously we're not interested in solving the puzzle. I just want to draw different letters. For example, my letter M will be like this. And this is, for example, if you go column by column, will be 0, 0, 0, 1, 1, 1, 1, 1. That will be the first column. Actually, the column number zeros, column number 1 will be 0, 0, 0, 1, and the rest zeros, etc. Let me show you. I already have the ready code for the first 3 letters. The letter M, instead of turning them on and off one by one and making our code look messy, some of the students already know this. Stuff like this, you declare separate functions. Now there's a function called M, which turns on the letter M on the display. First, I clear the display for whatever is already there. These 7 rows are what I just showed, already written in the code, and then 500 millisecond delay. Here, instead of setting the row, if I just write M, now it will turn off M. It will, when I call the function from void loop, it's going to execute everything inside M, and then wait, and then clear, and then wait. So it's going to blink M. Let me compile again, verify everything's correct. After doing this, let me import the other 2 letters. I'm going to upload this code and leave it in to GitHub and leave the link in the description. They can just use mine for the first 3 letters and try to do the other 3 on their own. Depending on how old the students are, they can also try to write their name, for example, instead of RMAT, etc. So there is a lot of work they can do on their own. I imported the functions A and R2. It's after void setup, before void loop. That's how it should be. Let me show you. And R and M, the functions already have delay inside of them. So I can just come here, erase everything in the void loop, and first call the function A, then R, then M. I compile. after doing this, let's try one more thing. So every time I want to change how slow or fast this is, instead of using actual numbers, let me do a variable. Again, some younger students don't have to do this. Instead of 500 millisecond, I want to make it 1000. And T, and T. So what this does, instead of changing the numbers one by one in the future, I can just change the variable. And see, now it's slower. If I go and instead of 1000 write 200, it will become faster. And the original was with 500 milliseconds. After doing these steps, they can try finishing RMAT. They can try to write their name on this. And in the future, I will also record an exercise of how to control the dot position with the joystick. And this is all for today. Thank you for watching, and see you next time.